Game development in assembly language. So we have sort of a Pong game in progress, and you'll notice it's a bit meh. It's like a little laggy, and I'll explain why. And there's also a ticking time bomb in it. And later on, as I get around to fixing it, you'll understand what I mean. But for now, what we're really just focusing on is the fact that this little paddle goes up to the top and disappears, and also it sort of like jitters. You can kind of see a jitter. And there's a reason for the jitter. The reason for the jitter is that even though drawbox is called inside the timer like it should be, the positioning of said box is being called move down and move up, see here, inside of the keyboard handler, which means it's rate limited by the keyboard handler. And that is why when I run this, if I do this, you'll notice a slight pause between when I click and then when it starts to go. And that is because it's a keyboard. So, signals are not getting sent in there at the same rate as the refresh. So what we need to do, and what I've done in other projects, is figure out a way to determine if a key is down or if a key is up. Okay, and this requires us to restructure our keyboard handler. Okay, so in order to do that, because I don't want to build out an entire table to handle every single key's input of down and up, what I will do instead is use variables for now. And even though probably not as good of an idea, it's something that will work and we can build from. So W is one of the keys we are using. So W down will be when W is down. Right now it's set to 0. S down will be when it's S is down. Okay. Now instead of calling the update on the move up and move down inside the keyboard handler, what we want to do instead is change that value to down or up. Okay, so we see a W press, we see a S press, and we also see an error. And the error we see is we are only checking for S, which means that if I press a different button, and we can just do this, okay, pressing W goes up, pressing S it goes down. But if I press T, it also goes up. So this is an error. Okay, so what we actually want to happen is say, okay, if using a compare, we find that the key val is equal to so jump if equal, JE, is equal to S, jump to S, and that makes sense, okay. However, if it isn't, it just goes on to W press automatically. So what we actually want here is another one of these. And we will say W, and then we will say go to W press, and then if it isn't equal to that, we're going to do a jump to done. Now, for the sake of this explanation, I want to make it obvious. So I'm going to go into the timer event and see this color's black one. I'm going to just comment out the drawbox there because I don't want to draw over top of the character write. And I'm going to enable character write on both. And you'll see what I'm saying. Okay, so byte. I need to say byte, right? 85, jump, done. Oh, colon. Okay, so if I press W, it goes up, and it's not clearing, so it looks like it's stretching. And you also notice that the character gives on key up is not removed from the, you still get a weird character there. And now if I press T, T's pressed, but it's not going up. And that's because we've added this. So I wanted to add that back in. But now we need to fix We need to fix the fact that we see a weird character when we do key up, because we need to be able to identify it So I noticed while looking over the code in preparation that this and AL is in the wrong spot. It actually needs to be in key up. Okay, so key up. Now I'm going to put it here because it's a little more clear that it's a separate operation from the actual key up operation, which I don't want to pollute, so it's going to be here. And then this needs to be duplicated. So for now, it will be here. We will be fixing this. It will not stay this way forever. Oh, and I didn't copy all of it, did I? Yes, okay. Okay. So now, if I press W, you just get a W on key up. And T, you just get a T on key up. Okay, so that's fixed. However, you notice there's duplicate code here and duplicate code here. So this really should be its own little function. So we're going to do a really quick little function to save ourselves a few bytes, and you'll see why that's important later. Okay, so we'll just call this key prep for the key value. Okay. And then it's probably return. And we're just going to copy this and put it in there. Yep, just like that. And then we're going to call it so. And we're not going to use the and because it only shows up there once or whatever. Okay, call key prep. And then we'll copy that whole statement. Call key prep and remove all of this. So now the code has gotten a lot cleaner. Okay, so it's been moved out. We can test it real quick. Okay, good. All right, but now instead of calling inside of key up and key down, oh, and we don't really need the right chars anymore. Okay. Instead of calling that, what we're gonna do is, instead of this move up, move down, we're going to be doing something different, which is moving a value into W down and S down. Yes, so where was I? Up here. Okay, so instead of move box up, on W press, we'll simply say W, okay, W down is our, okay, yeah, move, and I believe it's a byte. And we'll just move a W in there. That way it's very clear what we're doing. And then on here, instead of this, we'll just move a byte, byte S down. And then it will be an S, obviously. So, but we will also need to do something key up. And on key up, we'll just say, okay, well, we'll probably reuse these. So we got to do if statements again. And then a jump statement. But actually, we don't need a jump on this one because key up just returns. So what we need instead, okay, we do need the same setup, I think, because it'll be a bit messy if I don't have this. This keeps it clean. We'll go ahead and just preserve. Okay, so W pressed. Okay, and here instead of this is the key up. We're gonna put a 0 in. Okay, so if there's a 0, then you know that, okay, it's not pressed. And then now we can move out the move up and move down of the box outside of the key keyboard driver sort of interface and into the timer where it is supposed to be. So what we'll do then is just say CMP byte and it's S down, okay, and compare it to 0, And then actually, I think it needs to be, we need to compare it to S. And then JMP, if it's equal, so if not equal, okay, if not equal, no. We need a dot skip. Okay, so we need to just jump, if it's equal, to dot skip. Otherwise, we do the next comparison. And we say if it's equal to W, and in here we do W, so it's the correct one, jump to dot skip. And then we need a dot done. And we need to say, okay, well, if you've skipped everything, okay, this will draw it just fine. Aha, I know what I need to do. It's not that I need to skip it. It's that I need to say, okay, if it's, if it's not equal, skip it. However, if it is equal, call, and then S is down, so down, which is, I think we can just do move box down. That's right. So if it's not equal, skip it. However, if it is equal, then we will do call move box up, I believe. And then I kind of think, okay, done can be removed for now, I think. And we'll see. I may have made an error. I don't know. Oh, that's right. I need to re-enable drawing the box. So it clears. Okay. Well, W definitely works. No, S stuff definitely works, but W does not. All right, because it's going to skip. We need to do the second check then. So we need to do a dot check. Okay. And the first one should be check. Okay. Just doing this from memory, so I haven't had to check my notes yet, which is nice. Oh. And now it is fast. Okay. However, we have a little issue, and that is when it draws, it disappears from the screen. And this was a mystery to me until I did a little bit of analysis and I figured out what was going on. It's disappearing because we set this SQY to a negative value, and then it gets multiplied by 320. So it's off the screen. So to fix that, there's a comparison you can do, CMP. And then you can just do compare EAX, which is where the value is, to 0. And if it's jump if less than or equal to, so if it's less than 0, or no, not equal to, less than, if it's less than 0, actually, no, if it's greater than or equal to, we jump, because we're moving somewhere. Okay, and then we need a label that is continue or whatever. And we'll say dot continue. Otherwise, if it's not, so if it's not greater than or equal to 0, we'll just set it to 0. So move EAX 0. I think you might want like XOR EAX for faster speeds technically. But yeah. Oh, and it has a problem. Oh, I used continue already. So we'll just say proceed, because that was used already. Here I am using, oops, wrong one. And now we've hit that that mysterious problem, that ticking time bomb, where times value -2 is negative. And you may be thinking initially, oh, this has something to do with this negative number. Oh no, it does not. It has to do with this line. Do you know what this means? It means there's only 512 bytes that we can use in the bootloader. So I've got a solution for this. We don't need to fill the pixel. This was an entirely different thing we needed. So we delete fill pixel. And voila, it works. Because there's less than 512 bytes. And look how fast it is. It still goes below, but it doesn't go above. So that's nice. It's at least kind of doing its thing. You can move it up really far, and then when you try to bring it down, it takes a while. Okay. But now, how are we going to produce 2 paddles and a ball if we only have 512 bytes? It seems like a challenge, and it might be a fun challenge, and we'll decide whether or not we're actually going to do it, because there's probably a way. A couple of things I thought of is that, you know, a lot of these square width things can be like constant values. They don't need to be variables, for instance. Okay. And if I was to sit here and say, okay, well, I want to draw the second paddle, we could do that. We could grab this draw box, we could copy it. And we could go here and say, okay, well, this one needs to be at 290 to be in the right position. You know, everything else can be the same. Actually, I think it's this one that's 290. Everything else can be the same. So if everything else is the same, we can just kind of delete this line, see if it builds. And it complains we need 16 bytes of space. So we go, okay, well, we don't need this, the Y, and we don't need, we do not need right char. So let's see if that works. And we need 5 bytes. Okay, well, this is just left paddle Y, and this is left paddle Y, but it's just moving up or moving down. I mean, maybe if we do a label that just says prep move, we can just combine these sort of actions that are happening into one, for instance. However, I think a label takes a byte, so that actually doesn't really save me much. So what I should do instead is have a value that's either 3 or -3. There might be a better place to save some bytes. Let me double check and make sure I didn't have anything crazy. Key prep in the handler, down and up. Press values. Okay, I know how we can save. Okay. Key down doesn't need to be this big. Or not key down. Key up doesn't need to be this big. Because they're just going to get set to 0 anyways. I don't need to check if they're pressed. If a key up happens, set it to 0. So we'll just do that. No checking whatsoever. Just blind zeros. No down needed, nothing. Just 0 it is. So don't key up, I guess. Or don't hold keys. Does it work? Oh, it works. Look at that. We have worked magic in our 512 bytes. However, this obviously can't go on forever. The next video will be jumping to sector 2. And sector 2 will allocate a bunch of memory for gaming reasons, and we won't have to deal with 512 bytes. However, I may experiment to see if it is possible, because I suspect it's possible to do in 512 bytes. So who knows? Maybe the next video will be me celebrating that I built Pong in 512 bytes. We'll see. And I guess nobody will know till then.